in series with A plus B plus C. First let's draw A plus B plus C. Plus means correct, that's parallel A, parallel to B, parallel to C. This is my pull down, so all NMOSes. This A plus B plus C is in series, so something in series, and that series transistor's input is nothing but series with C out bar, so this is going to be C out bar as the input. And we know that adder is a symmetric circuit, so the pull down and pull up will exactly be the same. So let's draw the pull up here. A in parallel to B, it's a plus, so parallel to C, A, B, C. The entire thing is in series with C out bar, so another transistor whose input would be C out bar. So that is nothing but the same input here. Correct? And if you understand this clearly, this both are shorted. Or if you are getting confused here, understand that the same pull down is drawn as the pull up, and technically it should look like this if it's confusing you. This is my pull up, this is my pull down, this is my pull up, this is my NMOSes, this is my PMOSes, this is C out bar input PMOS, and my NMOS which I just connected has input C out bar, and the output is taken from here. So I have implemented part 1, I have implemented part 2 which is nothing but the series, and I have implemented part 3. So the output is taken from here. So this entire thing is in parallel to A, B, C. That means A in series with B in series with C. So let's quickly do that. A in series with B in series with C. A, B, C. Same we'll do it for pull up also. A, B, C. This is my VDD. And between the two of them I'll get my final output. So this output, as we have just said, is nothing but connected in parallel, right? How this became parallel is, this is how it's going to be. So both of them have common VDD, have common ground, and outputs are taken like this. So they are connected in parallel, correct? This entire circuit is connected in parallel to this circuit is connected in parallel to this circuit. Because this is output, this is ground, here also this is output, this is ground, this is VDD, this is output, this is VDD, this is output. So it's connected in parallel. So this is nothing but the inputs A, B, C. And this final thing what I get here is not going to be sum, but it's going to be sum bar, because I have not taken inversions here. I have straight away implemented this. So if I want sum, what I need to do here is I need to connect an additional inverter at the output, and this is going to be my sum logic. So very straightforward, isn't it? Total of 24 transistors. We'll draw this entire circuit again on the next page so that you are with me, but it's very straightforward, very straightforward. Here we have total of 10 transistors, here we have total of 8 transistors, and here we have total of 6 transistors, and if we count the 2 transistors in an inverter, this will go up to 26 transistors, correct? In case if you want your C out bar also to be inverted, you will connect an inverter here which will give you your C out. So that makes a total of 2 transistors for that as well, because we know that the inverter circuit is nothing but a PMOS and an NMOS. So this is my VDD, this is my ground, this is my input, this is my output. So 2 transistors for the inverter for C out bar to C out and sum bar to sum. So that makes a total of 28 transistors here. 24 transistors plus 2 transistors of an inverter for sum and 2 transistors of inverter for C out, and this is a total of 28 transistors. I've just drawn the entire circuit for your reference here. Where we first wrote the equation, we wrote C out in terms of C in AB plus C common into A plus B. I have implemented that here. A in parallel to B, which is connected in series to C. The whole thing is parallel to A in series with B, exactly same as my pull up. The output which I get is not going to be C out, but it's going to be C out bar, because there is no inversion present here. So to get C out, I'll draw an inverter which is something like this, and I get C out. So C out bar now is in series. So this is a series to A plus B plus C, parallel A parallel to B parallel to C. Again the pull up is going to be same, A parallel B parallel C. This entire thing is in series with C out bar. So series means a series transistor will have to connect for PMOS and NMOS, and its input is nothing but Cout bar. Now this, what I get is the output which I get here. This entire thing is in parallel. Parallel means the VDD, output and the ground. VDD and output should be same for the pull up, and output and ground should be same for the pull down. So that's exactly I am done. This entire part is in parallel to A, B, C. A in series with B in series with C. The pull up and pull down are same. So A in series with B in series with C. And this gives me my final sum bar, because again there are no inversions. So it will give me an inverted output. And if I want a sum, I'll connect an inverter again. So this gives me 10 transistors. This gives me 8 transistors, 6 transistors, 2 for Cout also 2. So total of 10 plus 8, 18 plus 6, 24 plus 4, 28 transistors. And I have implemented my sum in terms of Cout bar. Very straightforward. Hope you have followed. Stay tuned and take care. Thank you very much.